Okay, thank you. I did understand nothing.
That's perfect.
Have you done some jokes, pardon?
Yes.
Okay.
I try to get them going.
I try to entertain everybody. Good morning, everybody. My name is Michael Kämmerer. I'm a product manager from Schöck, Germany. In this job, I'm responsible for the development of new products, all services, all certification and approvals which we need in all around the world. The products I'm responsible for are sold in Australia and Canada, and in between there are a lot of different regulation and requirements, so I have to do a lot to fit each product to each country. And today it's a great pleasure for me to present you the newest development of Schöck Tronsole. Who knows Schöck Tronsole already? Okay. Then I should start in the beginning. Where is it used for and what is the special requirement for this product? Schöck Tronsole is a systematic impact sound insulation system. And sound insulation is quite important, I think, because it affects our health, because acoustic sound, acoustic noise can influence our sleep, concentration, sleepless, and all these effects. And all this leads to a depression mode, and that's the worst case because that influences our health and safety. But what kind of sounds, what kind of noises are there? First of all is airborne sound. This can be created by music, voices of people, and something else. The second one is structural-borne sound. That sounds in the walls, in the slab, and in the roof, and everywhere. And that can be created by construction machines which are connected to the building and something else. Tronsole itself is for impact sound. Impact sound is usually the way where we create sound in the building, in the structure, due to steps, due to some movement or something else. And the Tronsole itself is developed to avoid impact sound on a stair. When you go up the stairway, you create steps. The steps create structure-borne sound, and that can be heard in each flat, in each apartment. And I think an apartment is a private retreat where we want to be undisturbed. Nobody wants to hear his neighbor, and our neighbors should not hear us. And the same applies to a stairwell. And now the issue is how to avoid the impact sound from the stairwell. First of all, how can we verify or fabricate the performance of a sound insulation system for a stairway? Therefore, there are different measurement methods available. The typical one is to measure, can you see this? Okay, the typical one is to measure the sound which comes from the stair into the flat. It's a little bit bright, sorry for that. That's the method because if you do steps on the stair, on the landing, then this will come into the flat, into the apartment. And that's the way we measure. In the first one, we have a receiving room where we hear the sound. Then we measure the sound with a step machine, which is created in one room. That's the transmission room. And in the first step, we have a solid connection between the wall and the landing, for example. Then we measure the sound in the receiving room. Afterwards, we do the same arrangement, but we insulate the landing and measure again the sound in the receiving room. Afterwards, we can calculate the difference between the sound with insulation and without insulation. And the difference of this one is the performance of the product. It's called impact sound level difference. Very simple, I think. Some questions regarding this one?
Yeah, how do you actually measure this? Meaning you have the isolators within the sort of
Yes, that's a typical arrangement. Yes, you can see here on the right side, that's a transmission room. You can see the white box, that's the step creator, which picks on the slab with a certain energy that's defined in the standard. And then we have another room with a very complicated microphone where we measure the noise in the other room. And that's what we are doing for both situations, with and without sound insulation. And so we can define the difference and the performance of the product with the sound difference. Okay, then we have a result, but what does it mean? Therefore, we have different ratings in nearly all countries. A lot of association created different tables to rate the sound. And on the left side, you can see the typical one for the sound reduction. That means up to 33 decibel. That's a real high performance product. Nearly, that's what you can't reach at the moment. But our target is between 83 and 44. That's non-audible or still audible, but very soft. And that's what our product Tronsole reach. We reach a level between 27 and 28 decibel. That's quite good in this way, what we reduced finally. The sound level 63, that's without protection. If you reduce the sound by 27, 28, we reach the level in between non-audible or still a little bit audible. For requirements in all countries, we have different requirements. We have in each country, because the sound protection is mostly regulated locally. So we have different regulations in each country. In order to be honest, for Estonia, I don't know at the moment all regulations which are required, what we have to achieve.
53.
53. No, quite simple. Then I think if you do this, use this product, you're on the safe side. That's great. But to reach this requires a lot of effort, because not only the product, also the way to build a stair has an influence on this, the reachable sound insulation. And therefore, how can we solve this? Because there are so many ways to build a stair. You can use precasted elements, you can use in situ concreted stairways and landings and all these things. And we have a wide product range to solve nearly each situation. So we can go a little bit more in detail. The first of all, you can put the most expensive product for sound insulation in your stair. But you reach nothing if you have sound bridges between the building, the wall of this stairwell, and the stairway itself. And you know, on the construction site, there are a lot of stones, there are a lot of dirts, and all of them can come into the joint between the stair and the wall. And each stone is a sound bridge. And if you insulate the whole stairwell, it doesn't matter if you have a lot of stones in the joint, it will destroy the whole result. And therefore, it's important to have a focus on this joint between this one. And we offer one type, it's called type L, which can be glued on the wall in the case of an in situ concreted stairwell. And you can put it on the stairwell itself if it is a precasted stairwell. So we have always a material which protect the joint for dirt, for stones or something else. That's what we recommend to use in order to avoid sound bridges in this small joint. That's how it looks in the best case. Then you can see there's a really clean joint, there nothing come in this joint, and it's always protected. Okay, that's the stairwell itself and the joint. First solution is a precasted stairwell. Then we have the stairway, which is precasted and put on the construction site on small corbels. And therefore, we have the type F for the corbel itself, when you have the connection between the landing and the staircase. And for the ground floor, we use the type B. That's for the last level, where you put the stair on the ground floor. There we can also offer a sound protection in this way. This additional dowel is necessary in the earthquake area to ensure the horizontal fixing of the stair. because when there is an earthquake, it should be in place, because if somebody wants to leave the building without a stair, it could be dangerous. But in the most cases, it's not necessary, because there is no horizontal load. Only earthquakes or some other special cases could create this. In our technical information, you can find a lot of details of this construction. That means how is to build the landing, because in this case, we need a separate insulation of the surface of the landing and the slab. That have to be done differently, independent from our Tronsole product. And there are a lot of small details how to solve each simple detail in reality. Also available on our website, where you can choose different situation and find how to build it and insulate. As I mentioned before, the dowel itself on the right side is only available in the case of earthquake. In all other cases, it's mostly fixed by the screed. That means the stair can't move without moving the screed. Next situation, very often used, landing and stairs are precast, concreted on construction site in one step. In this case, we have to fix the landing and the stair itself. For the connection between the slab and the stair, we can use type T. It's placed first in the slab, and afterwards, when the stair is reinforced and everything itself, it will transfer the load from the stair into the slab. And the sound insulation is within the small white boxes. There are small foams inside which insulate this connection, and therefore we can protect or insulate the sound transmission from the stair into the slab. For the support of the landing, we can offer type Z. That are boxes which are placed in the wall, also with special reinforcement, and then can transfer the loading from the landing into the wall itself. So the whole system is fixed, supported, and sound insulated. Also for this situation, we have several details available on our website and also on our technical information, where you can find the minimum dimensions, where you can find the reinforcement which is required, and so on, and which additional insulation for the different parts are necessary. Next one, precast solution, precasted stairway, precasted landing. In this way, we have to insulate and support each part separately. As you have seen before, we can use type F to bear the stairway itself on the top and on the bottom. And additionally, we have the type P for the landing. And the landing is supported here in this case with 4 places. And there we have also the foam inside, the elodur it's called, where we can insulate the system, and we can transfer the vertical load of the landing and in the wall. Also for this one, there are different details available on our website. And you can see here again the bearing situation for the stair on the landing on the left side, and on the right side, the connection for the landing and the wall of the stairwell. And here you can see already a small disadvantage of this system, because in the case of a precasted stair landing, we need a hole in the wall where we can put in the dowel and the wall box. And this is sometimes not possible to have a hole there, because if it is in the outside, if you have a slab in the inside or something else, it's difficult to have this wall, and it is an additional effort later on that you have to fill this hole. In the case of special concrete, if you want to have a special concrete surface, you can see it always, this small hole afterwards. So there are some disadvantages. And that leads us later to our new development, which we start now, or started 1 year ago, and will publish next year in March. Another solution for spiral staircases, also very often used in smaller houses. In this case, we need special types. It's called type Q, because this type allows us to have a certain angle for the supporting, because there's a round bar inside on the bottom of this dowel, which allows us to move this dowel a little bit, because always you have the reinforcement in this direction, parallel to the stairway, and therefore we can place the sleeve a little bit in this angle in the reinforcement, and can transfer the vertical load by this dowel with this special round end on one side. Also, this is available for in situ concrete on the right side, and also the same problem with the precast element, that we need a hole in the wall where we put in this dowel bar and this wall box. And that creates an additional effort due to this hole. This hole have to be filled afterwards. You have to wait until the mortar is cooled, and so on and so on. And therefore, we developed a new solution. And here you can see the small round area where the dowel can move a little bit when the sleeve is not in a horizontal way, but in a certain angle. So, in order to avoid this hole in the wall, we developed a new product. New product is called Tronsole M. What is the target of this product? In the moment we have this situation, we have two walls, we need this hole in the wall, and the landing is placed, and we have to put in the dowel and the wall box from the outside. And afterwards we have to mortar this, and sometimes it's impossible to load the landing until the mortar is cured in the hole. So therefore it's difficult to use and difficult to place. The target was from our customers to have a landing with the dowel inside, and we want to move only the dowel in the wall and fix them without any mortar, without anything with additional necessary. As you know, we have some tolerances on the construction side. If we have used a standard product from our product range, it could happen that the landing is not fixed and it's in a certain angle, and nobody is satisfied with this. And therefore, we have asked our customer what are the requirements for such kind of solution. So the requirement especially was a mounting of the stair, or of the landing. There are no mess with mortar, because there are solutions available on the market where you have to create something tight in the joint. The joint is 2 centimeters. How to create this is very difficult. And also to avoid sound bridges. If you use mortar on the construction site, it's a very fluid material. It goes in each direction, it goes in each small crack, in each small joint. And afterwards you have a lot of sound bridges in the joint. Furthermore, the tolerances are more important, so we allow a tolerance with the product later of 32 millimeter horizontal and vertical. That's the tolerances which are required, the accuracy on the construction site to place boxes on the wall. No hole in the wall, I mentioned it before, and can be loaded immediately. That means it should be bearing directly after installation of the landing. At least 70 kilonewton load bearing capacity per dowel, and can be mounted from above and below. We will see later what does it mean. And 90 minutes fire protection. That was the minimum. We have also tests for 120 minutes, because in a lot of countries 90 minutes are enough. In some other countries are 120. In the current approval, we have 90 minutes, because it's based on a country where 90 minutes are the maximum required. But we have also tests available which shows it working also 120 minutes. How does it work? I think to explain how it works is the best fit if I show a video which is created in our laboratory. In this case, we have the wall boxes already installed in the wall. There are two different types I will explain later. Then we have to place the wall first, the landing first. Then we can move the dowel out of this to do a small hole on the top. Now it gets a little bit more complicated because we have fixing aids which have to be put on the dowel and markers which have to be placed on the wall. You can use nails, you can glue it on the wall. It's on your choice. This fixing aids helps us later to find where's the position, the correct way for the landing and for the dowel. This is necessary for each connector. When you have finished, it looks like this, that you can see the markers on the wall. After this procedure, it's necessary to remove the landing again. Therefore, we have to move the dowel bar back. And remove the landing that we can see the opening in the wall. And now you can see the fixing aids. There are two things available. I will explain later why. A small one and a big one. Now it can be placed in the wall box. And we have steel plates which are part of the delivery, which can put under this small box and beside the small box. Besides, it's necessary when you want also transfer horizontal load. That's what we call VH. Then later this dowel can transfer vertical and horizontal load. And for negative loading, we put one metal sheet on the top of this. This one is a VH. We can transfer loading in both directions. This one is a little bit bigger. And here we can place the steel plates below the dowel bar and above. And this allows us to transfer vertical load, negative and positive. But we have a big hole, so we have no horizontal load transferring in this one. Then put the landing again. Place it exactly to ensure the joint width. And then move the dowel bar out. The whole mounting, what we have seen here, in reality needs approximately 20 minutes. It looks a little bit longer here. The full video is now 4 minutes, but we installed this landing within 20 minutes. And now you can load it directly because it's already fixed. Everything is finished, and we can transfer all loads directly. Questions regarding this installation? Not yet? Maybe in reality, we will see. You have seen a lot of parts which are necessary for this one. First of all, we have two parts for the sleeve. One is for the installation of above, and one is for installation of below, from below. Sometimes it's possible to come up from the top and move the dowel outwards. Sometimes it's impossible, then you have to move the dowel from the bottom. So it depends on the situation. Furthermore, we have different kinds of wall boxes I have explained before. One is the right one is for horizontal and vertical load. It's called VH. And the left one is only for vertical load. So there's a wider box in the wall where the dowel can move afterwards and have no transfer of horizontal loading. Furthermore, we have the dowel bar itself and a locking pin. This locking pin is necessary during the installation, because if you have the dowel bars in the sleeve, and you move up, they can come out, and that could create some dangerous. If somebody gets it on the head, it's not healthy. Therefore, during the installation, this pin lock is used to fix the dowel, and also afterwards, after installation, you should put it in to be sure that this landing is fixed all the time. And the fixing aids, you remember maybe in the video, that are also necessary to place the different boxes in the correct way. A lot of parts, I know, and therefore we offer only 2 sets. One for the precast plant. It depends if the installation from the top or from the bottom is necessary. We have a O from above and a U from below. And we have the parts which are necessary for the installation on the construction site. It's the fixing aids, the pin lock, the metal sheets, the wall box, and the dowel bar itself. That's the set which we send to the construction site for the installation. Furthermore, we have some accessories. The fire protection collar, which is required during to protect the system in the case of fire. And we have a metal sheet, a steel cover to close the opening. In the most cases, it will be concreted that you can't see it anymore, but in some cases, some architects want to see this and want to see a stainless steel plate, as we can see in a lot of walls. And furthermore, we have a fixing aid for the precast plant, because how to install or fit the sleeve in the precast plant in the right position. Therefore, we have this fixing aid. Therefore, there's a hole in the formwork necessary. You can fix this aid on the formwork itself, put in the sleeve, and if you start to drill this nut, then it will get wider and fix the sleeve in place. Questions regarding mounting and...
So, Michael, you had at least 5 different systems that you introduced to us.
Yes.
But then how do you compare them, and do you have a good sort of data for each one of them?
Yes, it's available in our product information. You can find there the performance regarding the sound reduction. Mm-hmm. And but they are all close, 27, 28, all in the system. When they are correct, if they are installed in the correct way. Yes, if you have one sound bridge, everything is lost.
So although they look quite different, they perform in the same way?
Yes, this year we reached the same performance, around about 27 decibel sound reduction.
Thank you.
Welcome.
You showed that these boxes were inside the blocks. But what if we have precast concrete that comes from factory? Then should we put the boxes inside them on site to make sure that they're level, or?
That's the idea of the system, that you can place it with a tolerance of 30 millimeter on the formwork. And then it works on the construction site, because then we can level the tolerances and have the possibility to switch the blades and put it in the correct way. But it's also thought the boxes to put it in precasted walls, and also the same for this landing, that we can put the sleeve there. Okay. Technical topics, important. The product itself is still in a development. That means we are preparing all documents. The final documentation for the approvals have to be finished in the end of this year. But you can see here the first estimation of the load-bearing capacity, independent of the thickness of the landing and the joint width. The system is developed for a joint width from 15 up to 50 millimeter, and the minimal edge distance from the center of the dowel to the edge of the landing is 150 millimeter. It's very close. And then you can see we can reach up to 92 or 93 kilonewton per dowel. So it's quite a lot. In this case, it's a little bit confusing, because we can see on the top the horizontal load. This one is for the strongest concrete, C30, 37. For smaller one, it could happen that the concrete cone failure is leading, and then we have some reduction on the right side, and depend on the horizontal load. But in this case, for a very strong concrete, it doesn't matter. The dowel bar itself is leading for the load-bearing capacity, and therefore we can reach up to 93 kilonewton. But we have a very high load. You know, the weakest point is the concrete itself. If we want to transfer a high load in the concrete, we require a lot of reinforcement. You see, there are a lot of stirrups necessary in the area of this dowel bar. These are small diameters. You can see it on the right side. Only diameter 10 and 12 have to be placed there by a certain number on both sides of the dowel. In order to transfer the loading and to avoid the concrete cone failure below this element. All this information you can also find later in our technical information. All the details are described there with how many bars are necessary there, which diameter and bending forms are required to install this. And fire protection, I explained it before. The fire protection collar is placed within the joint. The number of fire protection collars depends on its joint width. If you have 15 millimeter, then only one fire protection collar is necessary. If you have more, maybe you have to place 2 or 3 of these fire protection collars within the joint. And it's placed directly on the dowel bar, that in the case of fire, it starts to swell and close the joint and insulate the joint so that it's protected from the high temperature. So we reach temperatures below 500 degrees, and that's not dangerous for the system. The load-bearing capacity is ensured for 120 minutes. Tested in our laboratory. Not in our laboratory, the laboratory of Poland. Questions regarding fire protection, dimensioning. Therefore, we will find later also different sketches and drawings on our website available. Also, the tool, the dowel bar itself or the system itself will be available on our CAD library, that you can download your CAD files for different systems and can put it directly in your drawings, in your CAD system. Okay, I'm still on the end. What I have shown today, I have shown that we have a solution for nearly each situation. For precasted, for in situ concreted stairs, we have different types. I showed type P, Q, F, T, B, M. That's a lot. But the target is that we have a solution for nearly each situation which is required on the construction site. A complete system. When we talk about sound insulation, we don't talk about only the load-bearing area. We have also to see it as a whole system and to avoid each kind of sound bridge. Therefore, the type L helps to ensure this in the whole system. And reliable sound insulation. All our products are tested on the laboratory close to our factory. And we have the situation that we can build up different situation according to the standard with all the required equipment and measure the sound insulation in several steps. We don't measure it once, we measure 2, 3, and more for each system. And then finally we create a safety design value for sound insulation. And I presented the new type, Tronsole type M, for a requirement of some customers. They want to have a dry installation of the landing with insurance of the sound bridges in the situation. Questions regarding this product? Ideas?
Yeah. Have you done measurements on the service life of the insulation? And does the insulating properties degrade over time and somewhat, or do they give the same for the whole service life of the product?
Yes, we measure this for each product. I have explained before, for each type, also for the type M, the measurement. At the moment, the value is not available. The reason therefore is we did 3 or 4 tests. Now we have to measure the or create the design value. Therefore, some statistics have to be made and so on. And afterwards, we can offer in our technical information the final sound insulation value. I think in the end of March, we will have all these values available, and then we will publish. And at the moment, you can't buy this, what I have shown today, because that's a new development. It's in development.
But
we have
the older products. But on the older products.
Yes, therefore all values are available in our technical information. So it's one of the first information that you find on the first page of each type. There you can find this value, how many decibel it reduced the sound level.
But over time, I think
Yes.
with 20 years from now, does the value is the value still 27 decibel or is it less?
Good question. We have some we have separate things. One is the measurement of the sound, and one is the insurance how long the system is working. Therefore, there are special tests to prepare, but it's done with the material, the heliisolatioon itself. That's the material for the sound insulation in all of these products. And therefore, we did temperature loading, we did salt loading, and all these things, because we can't wait 50 years with the system. We develop faster a little bit. And therefore, we can only do some standard tests to load or create different environmental conditions, which hopefully ensure the lifetime of the system. Yes, it's also for the most systems available in the market. If you're calling about galvanizing, if you're talking about other things, when you try to find out how long it works, there are standard tests for that one, but it doesn't ensure, it's no guarantee. It's the best way we try to find out how long it works. And so we reached 50 years with the system because there's no changing in the material itself.
Yeah, the question stems from the responsibility of serving for 50 years.
Yes.
And we, as constructors or designers, have to ensure that the 50 years is covered.
Yes.
Then, yeah, we also see these materials in real life, and especially historically old materials.
Yes.
They survived pretty much anything. Like the rest of the building was in scramble, but then the core was fine.
Okay.
So without the UV light and without the sort of environmental effects, the materials survived quite like they seem to survive forever. But,
Yes.
it's a difficult test though.
Yes, it's for the inside using of the product. It's quite simple because there we have very constant environmental conditions.
That's right.
But sometimes also used in the outside, and then we have other. But in the most cases, it's behind the insulation. Yes, if you go through the wall in the wall box, then the wall box itself is behind the insulation. Therefore, it's mostly in the same level. This one.
Ich frage auf Deutsch und antwortest dann.
Okay.
Also, jemand möchte was. Wir haben verschiedene Types. Wir empfehlen, was wäre besser für die Situation. Oder Kunde sagt, ich möchte das und dann.
Yes.
Wie wählt man, was wäre besser in bestimmten Situationen? Wie funktioniert das?
Okay. I repeat the question first. He asked, how can we recommend the correct type for a special situation? I think it comes out of this presentation. It depends on how the stairwell is built. Is it built as a precast element, only the staircase itself, or is it the landing precasted, or what is used in situ concrete? And what is a precast element? Precast elements are very common for stairs in a lot of countries. I think so is Estonia too, and therefore it depends on the way of construction. If you have, for example, the connection between a stair and a landing, in the way of a precast element, you should use the type F with a console. And if it is an in situ concrete stair, you should use type T. That's with the product with the white boxes, which are filled on the construction site with concrete. It depends on the way of construction, and therefore it's very helpful to see this presentation. For each detail, for each kind of construction, you will find the correct product type. Yeah. Okay. Oh, yes, yes. We have a sample, but we can't load it. We will find it here. Okay. Maybe later you can see it there. There's a sample. It's a 3D print made of plastic. The load bearing capacity is not 93 kilonewton, maybe a little bit less. But you can see and understand how it works. And therefore it's quite helpful, that one. If there are no further questions, I thank you for your attention. And I'm still here, so you can ask later some questions regarding this product. Maybe it's quite helpful. It will be available in the first quarter of 2026. It's still under development.
Thank you.
Thank you.